So let's suppose we're working for a biologist who's just discovered a new species of tiger cat in Brazil. So one on the left is the biologist, the one on the right is the cat. Now we're collecting data on this species, and the variables that we're actually recording for, well, they're sex, weight, length. We're actually interested in what state the cat was found, the state of Brazil, and we're also interested in the number of spots. Okay. Ideally, we want this information for every single one of these tiger cats. And we refer to that idea, all of them. So in this case, we've got a unit of observation, which is a tiger cat. And we refer to all of the tiger cats, or in general, whatever our unit of observation is. We refer to that as the population. So it's a statistical population. And in general, a statistical population is any set of things that have something in common. And in this case, we've got a set of cats. And what do they have in common? Well, they've got being a Brazilian tiger cat in common. However, finding every single one of these new species of cats is probably going to be very expensive, and not to mention that it will seriously disrupt the habitat of this species. So, whilst we would like to know about the entire population, we'll have to settle ourselves with just finding things out about some of the cats. And we call some subset, just some of them, when we actually have all of them, we call this a sample. We call this a statistical sample. In general, a statistical sample is simply part of the whole population which is selected in some way. However, in reality, although we want to know about the whole population, we don't actually want to know every single thing about every last single cat in the population. We just want to know some broad, overarching facts about the population. So these could include a list of inquiries, what the average weight is. But they could also include something like, I want to know how much does the number of spots vary? Okay, and so we call these facts about the population, the properties of the population, we call these parameters. And so we have, for a population, we have parameters. However, we don't know these parameters. We want to find out about them, but we don't have every single last cat, and so we can't compute the average weight for the whole population. We can't compute how much the number of spots varies. We only have information about our sample. And so we can compute these things for our sample. And so just like we have parameters for the population, we have statistics for the sample. Now, that might be a bit confusing at first. You might be thinking, statistics, isn't that what we're studying? Well, this word here doesn't mean the field as a whole, doesn't mean, what we're learning. It means some property of the sample. Now, since we only have data from our sample, we have to satisfy ourselves with these statistics. But our ultimate goal is going to be using these statistics to find things out about the parameters. And we'll be covering that from now on.